For this lesson, we're going to focus on factoring quadratics and how this relates to the graph of the given equation. So let's start with x squared minus x minus 12 is equal to 0. To factor this thing, I want to try to use a guess and check approach. That is, we should be able to split this up into two linear factors. And to make our guess, we're going to focus on this -1 that's in front of the x and this -12 at the very end. So to start this, I know both of the linear factors have to have an x and an x. When we multiply these things together, that's where the x squared comes from. This x times this x gives me the x squared. To figure out this -12, we'll place numbers after the x's, and the product of those two numbers should be -12. So we know a couple of things like immediately. I know that since the last term is -12, we have to have a positive and a negative. And now we just have to think of, and I'll write this down. So we have 12. We need two numbers that multiply to 12. And I think I can list a few of those out. Like you could have, 1 and 12. You could have 2 and 6. And you could also have a 3 and a 4. But we want to choose this in a way so that when we add the numbers together, it gives me this -1 in front of the x. So for this example, that will be if we use a +3 and this -4 at the very end. And we can check by multiplication, multiplying this out, that this is in fact how to factor x squared minus x minus 12. So that is, if we do x times x, that gives us the x squared. If we do x times -4, that is -4x. If we do 3 times x, that is a +3x. And then the +3 times the -4 is equal to a -12. Combining all that together, we in fact get x squared minus x minus 12. So, okay, I know this in fact worked. Great, so we factored the quadratic. I'll write that down again. We have x plus 3 times x minus 4 is equal to 0. Now from here, we can use these linear factors to actually solve the equation. We'll write each linear factor separately and set it equal to 0. So let's see. X plus 3 equals 0. If I subtract 3 from both sides, I get -3. And if I add 4 on the other equation, I get x is equal to 4. And these are the two solutions. Like the way I think about this is, well, here we had x plus 3. If you put a -3 right here, clearly that's going to give you 0. Likewise, okay, we have x minus 4. If I put a 4 here, 4 minus 4 is 0, so I know both of these things are solutions. Now the question is, how does this relate to the graph? If you graph in your calculator y equals x squared minus x minus 12, these two solutions are where the graph crosses over the x-axis. So here we have one spot, here we have a second one, and the one on the left is -3. The one on the right is a +4, which matches up perfectly with the two answers that we have over here. So you really could even just use a graph to answer this question. You could look to see where the graph crosses the x-axis, and those must be your solutions. Now just a little terminology. These two numbers, -3 and 4, are called zeros. So that is x is equal to -3, but also x is equal to 4. They're the numbers that make the graph equal 0, which is why they're called zeros. Now, those relate to what we call factors, which is x plus 3 and x minus 4. So it should be clear that, okay, well, if x equals -3 is a 0, it's got to be that it came from the factor x plus 3. Notice it was a -3 here, and it's a +3 here. Likewise, if x equals 4 is a 0, it's got to be that x minus 4 is a factor. So this works in both directions. If you know a 0, you know a factor. And if you know a factor, you know a 0. So you can check all of this work just by looking at a graph. For example 1, let's try this process again, but with just a slightly more complicated equation. So here I'd like to solve 4x squared plus 12x plus 5 is 0. And to do this, I think I'll just copy the equation down again. And if it factors, we should be able to set up two sets of parentheses that multiply back to the original equation. Here it's more complicated because you can't just have an x and an x. We have a couple of possibilities. It could be, well, maybe it's going to be 4 and 1, or if we're able to guess it, maybe it's 2 and 2. So it's really a trial and error where we're just going to pick a possibility and see if it works. I'm going to try 2 and 2. When I multiply 2x to 2x, it definitely takes me back to 4x squared. Now, if I look to the 5, this actually isn't so bad because, okay, there's only really two possibilities that I could guess that multiply to 5. It's got to be a positive 1 and a positive 5, so I'm going to try that. So let's see if this works. Does this give me 4x squared plus 12x plus 5 is 0? So if we multiply it out, we get 2x times 2x, which is 4x squared. We get 2x times 5, which is 10x. We get 1 times 2x, which is 2x. And then our 1 times 5 we know gives us a 5. And okay, yeah, this combines. We have a 4x squared. The middle terms add to 12x. Okay, so this in fact did factor. We factored it correctly. Maybe you can't get it on the first guess, but if what you tried didn't work, then just go back and try some different numbers. It might take a couple of tries, but you'll definitely get there. So now that we have two factors, I'll set them equal to 0. So we get 2x plus 1 is 0. And 2x plus 5 is 0. If I subtract 1 on the first and 5 on the second, and then divide both by 2, I get two different solutions, -1/2 and -5/2. So over here on the right is my graph of 4x squared plus 12x plus 5. It should be that this 0 appears on the graph, and so does this one. Okay, so if I check this out, it's not lining up perfectly, but I have a value here and here. If this was in your calculator, you could check this in your table, but I mean, the -1/2 looks good. I mean, this spot right here, it's between -1 and 0, so that is reasonable that that would be -1/2. Okay, this other one here is between -2 and -3, and well, -5/2 is -2.5. I mean, it definitely looks like both of these zeros match up with what appears on the graph. And if you knew these two zeros, you would also know the factors of your equation as well. So that is the answer to this question, -1/2 and also -5/2. And for example 2, a slightly different equation, it's just written a little bit differently, but it's still a quadratic. When is 3x squared plus 4x equal to 16? So to solve this one, we have to make sure that one side is equal to 0, just like in the two previous examples. And to do that, I'm going to subtract 16x from both sides of the equation. If I do that, I get 3x squared, and I get -12x is 0. So this should be a first step if you're trying to deal with a quadratic equation that you're going to solve by factoring. Get one side equal to 0. And once you have that, take what's left over and try to factor it apart. This one's also a little bit different because there's no constant term at the end. It's just a 3x squared, a 12x, and then there's no plus or minus some number. So to factor this, I think it'll actually be a little bit easier where instead of setting up two parentheses, I'm going to look between the two terms and say, what is the most I can take out of both? What's the greatest common factor? So between the two of these, if you focus on first the number, there's a 3 and a 12. The most you could take out of both is going to be a 3. And if you look at the x's, you have an x squared and you have an x to the first. That means the most that you could take out of both is an x to the first. So really just 3x is the greatest common factor. We should be able to write this as 3x times whatever is left over. So for this first spot here, if you take out a 3 and just one of these x's, you're left with just an x. I'll copy down the minus. And on the second term, if I take out a 3, I'm left with 4. You took out the only x there is, so this is it. This factors slightly differently, but it still is two pieces. I have 3x and x minus 4. To solve where this thing is equal to 0, I'll take the same approach where I take 3x and set that equal to 0. I take x minus 4 and set that equal to 0 as well, and then just solve both of those equations. First one's pretty simple. By dividing both sides by 3, you get x is 0. And on the second one, you can add 4 to both sides. And these are the two solutions, 0 and 4. You could check this by looking at a graph or plugging them back into the original equation, but I'll leave it at that the two solutions are 0 and 4.